Hey everyone, thanks for joining me today. I'm going to be talking about how you can configure an LLM to talk to a database. This has been possible for a while, but has been made much easier recently with the development of MCP. I'll talk more about that in a minute, but let's dive in and get you going on how you can connect your LLM to your database. To do that, we are going to use Olama and a few other things, but let's get started with Olama first. So if you haven't heard of Olama, it is essentially a host to let you run models locally. So download Olama. Depending on your system, you can come here and choose which way you want to download it. Once you've downloaded it, you'll want to pull a model. Now, you don't just want any model. You want a model that is aware of tools that will let you use an MCP. And so for now, when you're looking at models to pull, click on the tools filter here, and it will show you all the models that have tool awareness. And you can choose one of those and download it. I downloaded Qwen 3, so that's what I'll be using in the examples today. But anytime I mention Qwen 3, you can just insert your model instead, and it should work. So download Olama, download a model. And to download a model, what you'll want to do is you'll say Olama pull and then the name of the model, so Qwen 3 for me. Since I've already pulled that, I won't need to do that. Now I can say Olama ls to list all the models, and we'll see that it is there already. And if you want, you can say Olama ps to see which ones are running. Right now, none of them are running, so we'll come back to that in a minute, but that is just fine for right now. Okay, next thing you'll need is Docker. You'll want to download Docker, get it running, and then you'll want to pull this image. This image is a Postgres database with a DVD rental database loaded in it. It's kind of a tutorial database, so I just was looking for something that had some data in it already, and this was one of them. So this is the database that we will use. Once you have Docker pulled down, that image pulled down, that is, you will want to run that image, and you'll want to run it, give it a name, give it a password, and open the ports. That's the important part because we want to be able to talk to this. We don't just want it running somewhere. So make sure you port forward so that you can talk to this image there. And obviously this is just an example. Password doesn't really matter, but if this were a production thing, you definitely want to have a good password there. And you'd probably not be running it this way. Anyway, so with Docker, with that running, we then get on to the next part. So we have a model, we have a database, we need some stuff to make those things talk to each other. And that is where Fast Agent comes in. So Fast Agent is a MCP client and something that you can use to connect to an LLM and coordinate agents and things. So if you haven't already downloaded Python, you'll need to do that. Python 3, go ahead, download that. Then make sure you download UV as well. Instructions are right here on how to do that. And then once you've got Python and once you've got UV, you can then install and set up Fast Agent, which has great instructions here as well. UV pip install Fast Agent MCP, and that will install it. And then make sure you run Fast Agent setup. That will get you going with a bare bones agent. That's what we'll use in this example. You can run this quick start workflow down here, and it will give you some more things. We'll talk about some of those in a minute. But just for this example, all you'd need is the agent file. So UV run Fast Agent setup. Then before you run the agent, let's talk about some configuration. So we have this local model, we have this database. How do we get things connected? The first thing you want to do is configure Fast Agent to use your local model. By default, it's going to use Haiku, which is one of Anthropic's models, which is fantastic. The problem with that is it needs an Anthropic API key, which if you have one, go ahead, use it, because you already know everything that I'm about to say. But if you don't have one already, you'll need to go to Anthropic and you'll need to make an API key and then pay at least $5 so that you can have credits to use with your API key. If you don't have credits, the API will error on you. You won't be able to use your key. So yeah, if you want to use Anthropic stuff, you just have to pay for it. Same thing with OpenAI or Google or DeepSeek. You'll need to go jump through their hoops to get it to work. However, if you just want to run locally, that's as free as compute power is on your laptop, which I don't pay your power bill, so it's free to me. No, it's yeah, there's basically no cost associated. So generic.quen3:latest is how you'll set up the default model. You can obviously replace Quen3 with whichever model you pulled. But for us, generic means we're running locally. Quen3 latest is the model we want to run. So I went ahead and changed that so that I didn't have to worry about those API keys. I do use those APIs, just I didn't want to do it on this example here. So now let's jump over to our agent.py and we can run this thing and it will pull up an interface with our LLM and we can chat with it and have a good old time. The only problem is it doesn't know about that database we pulled down. So how do we connect the two? That is where the Postgres MCP comes into play. Now, I'll talk more in a minute about what an MCP is. For now, just think of it as a tool that allows your LLM to connect to other things, in this case, a Postgres database. So here we see the information about the Postgres MCP. We're going to come into our fast agent config again, and we're going to scroll to the bottom where it says MCP servers, and we're going to add a Postgres MCP server. And in this example, we're just running locally. So again, we're doing npx, and that's going to pull down a package, specifically the server Postgres model context protocol package. And then we're going to tell it, we're going to give it a URL to connect to. And that's just a standard Postgres URL because we're running locally. It's going to have localhost, the password and user that we sent. And then this is the one important part is the DVD rental is the database name. So on the end there, you want to put DVD rental. And that configures the MCP to be used with our agents, with our LLMs. Then what we want to do is come over to our agent file again, and we're going to add a servers parameter, and we're going to say it has access to the Postgres server. And because that is what we called it over here, it's Postgres. So with that, it will then know that it has a tool available to it and it can run queries. Okay, so our output came out down here. Quen3 isn't the fastest on my machine because it is a little bit of a bigger model, but it did respond and it told us also how it thought about it. So that's really cool. As you're working with LLMs, if they display their thinking process, you should read through those. Not only are they kind of fun, they are insightful because a lot of times there's thinking errors that crop up in LLMs, and by reading its thought process, you can help correct those thinking errors and know where it went wrong. Okay, let's exit out of that and run it again with the tool. And then we can ask it something like, how many unique films are in the we'll say are in the system. In the system. So I'm not mentioning a database specifically, but it should know that it has access to a database and it should invoke the tool. We'll see if it figures it out. Sometimes it doesn't, but we'll see if it knows that. So I said we'd talk more about MCPs. Let's do that. Before we get to MCPs, though, we kind of got to go a little bit back and know why they came about. So back in November 2022, OpenAI released ChatGPT and LLMs were thrust into the limelight. And everyone was using them for various things and realizing the benefits, but also the limitations of LLMs. They're great at natural language. They're great at generating things. They're great at problem solving. They're not great at math. They're not great at SQL. At least they can't connect to databases on their own. They're not great at getting you an Uber or ordering pizza or booking a flight. There's just things they can't do because they don't have access to it. So as LLMs developed, people wanted to add more and more to them. They wanted to give them access to various things, to databases or to the internet or different things so that they could have different contexts and information available to them. But to do that, you had to write a lot of glue code. You had to write a lot of custom stuff that just connected the LLM to the tool, and there was no standard way of doing that. And so if you went from one project to another or from one company to another, you'd see that they did things differently. There was no standard way of providing these tools. And Anthropic is one company that does a lot of AI consulting and projects for customers. And they saw this problem and decided to do something about it. So in November, again, of 2024, just 2 years after ChatGPT blew everything up, they introduced Model Context Protocol. And this is basically a standard that was developed so that you could provide additional context and abilities to your models. And so you could connect them to databases. You could give them access to the internet. You can connect them to Google Maps or whatever else you want to do. But it kind of went under the radar until about April of 2025, when there was a presentation at an AI summit from one of the lead developers about Model Context Protocol. And around that time, as well, as when Google and various others decided to back Model Context Protocol, including OpenAI, which is one of Anthropic's competitors. So the adoption in the industry has really picked up. There's still many MCPs that need to be written. And please go out and write them, especially if you work for a software company. People want to talk to your app through their LLMs. Please make those MCPs. But yeah, while there's still many to be written, there are many useful ones available right now, such as the Postgres one that we're using today. So we've got our response. We asked it how many films it knows about in the system. We see that it tried 2 times to get that answer. The first time it said, let's select from films. But films doesn't exist. If we come over here, I've listed all the tables in the database and we see film, but we don't see films, plural. So it rightly got an error message. It decided, that didn't work. I need to try something else. So it tried to select from film instead. And we see that it got the right answer. It got 1,000 films. And again, we see its thought process and it says there are 1,000 unique films in the system. So there we see it doesn't know the database. It had to discover it on its own. So what if it did know the database? Here I've got a prompt that I've written as I've been trying to film this. Each time there's a problem filming it, so hopefully this time there's no problem. But I have this prompt now kind of down. We say, not only are you a helpful AI agent, which is all we said before, we now say you're a helpful AI agent with access to DVD rentals database. So right there is more context than it had before. It knows it has a database and it knows it has DVD rental information in there. Then we tell it the tables in the database, and then we say, you answer user queries about the database and fetch data from it to answer their questions. And then we provide a little bit more information about what the tables contain and kind of how they're related together. So with that, it should do a little bit better. We're going to run the agent again. It's going to get that system prompt. So that's already injected in the context. And then we can ask it more interesting questions, such as what are the most rented films? We're going to say movies. Obviously, it's an LLM, so natural language is its thing. So it's going to know film and movie, same thing. And it's going to be able to derive the query that it needs to run to join the right tables to answer this question. It may need to iterate a little bit because we haven't told it, well, we've told it some of the, actually, no, we haven't told it any of the actual names of the columns. We've just said the type of information that it has. So it may need to iterate a little bit on the query that it does, but we'll see. Okay, So yeah, Anthropic noticed that from project to project, there were different ways of providing context to the models. So they wanted a standard way to do that, and they made an MCP, and now the industry is really getting behind it. So there's a great opportunity for many companies to build MCPs so that users can access their apps through their large language models. Now, not everyone runs one locally. If you downloaded Cloud Desktop, you're running an MCP client, so you could connect various MCPs. It's pretty easy to do. It's basically just adding things like this so that you can connect to different things. So Cloud Desktop would probably be the most common one that people can use, but there's various clients out there that support various aspects of the MCP protocol. Fast Agent is one that supports all of it. So they support everything in the MCP. I think Cloud Desktop is probably close to that as well, if they're not already. But yeah, there's various aspects of MCP that can be supported. Let's talk a little bit more about MCP and why it's kind of a big deal. So here is a general overview of how it works. So you'd have a host such as Cloud Desktop or Fast Agent or Visual Studio Code. You can configure these in GitHub Copilot tool as well, which is awesome. You have a host that runs MCP clients. And these clients you configure to access different servers. These servers can be Docker images, they can be packages that npx runs, or they can be different servers and things. Usually if it's a server though, you'd have a package that talks to it. But anyway, you can configure these and they can run locally, or they can reach out to external sources to run that MCP. So that's on your MCP host. Your MCP host may or may not run the server on the same machine. It may reach out to other places, but then that server could access local things if that's how it's configured, or it could reach out to other things, remote things. That's kind of how our Postgres one is working. It's just that we're hosting it locally on a Docker image. But for all intents and purposes, this URL could be AWS or somewhere else, and it could talk to it. So yeah, you have a host, you configure clients on it, and then those clients connect to those servers, and the servers may be running on your machine, but maybe somewhere else, and you can communicate with whatever they're configured to communicate with. Sometimes if it is using an API, you might need to configure an API key for it to use. But yeah, you can come to mcp.so. There's a few other sites as well that kind of list all these things, but mcp.so shows a lot of MCP servers, such as GitHub, Playwright, Slack, Google Maps, Brave. There's a lot of MCP servers that are out there, with many more hopefully to come, adding more and more capabilities to LLMs. So yeah, with MCPs, another great benefit of MCPs is you can offer AI abilities to your customers without running a model yourself. You can provide tools to their models so that they can interface with your application, but you don't need to run a model yourself to offer them AI capabilities. They already have an LLM, and I mean, not every company does, but many people are using LLMs, so they can configure their LLMs to talk with your app. So that is one benefit, a little cost saving to you as a company, and still enabling AI abilities with your application. One thing to think about though is in our situation, we are connecting our LLM to a database, and it actually does a pretty darn good job of taking our natural language, transforming it into a SQL query, and then telling us the result in natural language again. So this is a great way for non-technical users to run database queries to get the data that they're looking for. They may need to know a little bit about the database schema if they get stuck or if the LLM runs into problems. But for the most part, they should be able to say, hey, this is what I want to know, and the LLM will take it, parse it, and return the result, and it'll be amazing for them. One use case that wouldn't be so good for this is a technical user. If you're using an LLM to just run database queries, that's kind of an expensive way to just connect to a database. You should just connect to it and run your queries. You don't want to have to host a model just to access your database. So yeah, if you are a technical user, probably just connect to the database yourself. Another consideration though is sometimes the database schema, LLMs may have a harder time parsing it versus a more natural language format, such as a document store. So if you denormalized your data and put it in a document store, then your LLM may have a little bit easier time of parsing it and getting the information that the user wants. I haven't tested that out myself. I really want to though, and see if it does any better. But the other thing that you may want to consider is you don't want to give access. You may want to think twice about giving access to your production data to your LLM. You probably want to set up a read replica or a document store or some other database store where the LLM can go and query its data rather than your production database. But that's kind of old hat by now. Lots of people know that at this point. Okay, so now we are seeing, oh, let's see. Did it? Okay, it got some data from the database and it said, wait, looking at the data, let's see. First, I'll check the highest numbers, 9 and 8. I don't know where it's getting this data from because we've got like 34 and 33. So yeah, even here it's hallucinating. It's not, I mean, it's The Matrix, Inception, Interstellar. I mean, it's matching movies that it's heard about, but it doesn't know which ones have been seen the most. So let's see. Right here, we see that we have Rocket Brotherhood at 34 and Rocketeer Mother at 33. Okay, so it did not get the right answer. That's actually the first time that I run this that it did not get the right answer. I've had it not be able to do it before because it didn't know the schema and things, but this is a straight up not using the data that was available to it. So that's interesting. We probably could ask it again, or we could ask it a different question and see if it does any better, or we could massage our system prompt a little bit to see if we can get a little bit better information from it. But yeah, let me see, did I clear it? Yeah. I did have a result earlier where it did provide the right answer. Really cool. And I did it multiple times. But of course, the demo did not work. So what are the most rented movies? Let's see. Which films were rented the most? Let's see if that one does any better. Let's see this. Yeah, so this example is an example of agentic AI. It's a very basic example, but it's an example. There are some other examples in here of different ways to use this. You can chain things together. You can orchestrate different things. You can have a router. Let's look at chaining real quick. So chaining is another form of agentic AI where we have multiple agents and we're chaining their results together. So we have an initial agent that does one task, we feed that result into another agent that does another task, and you can do that, for however many steps you need. You're kind of building a workflow. So here in this example, we have a URL fetcher where we get a web page, and then we have another agent to write a 280 character social media post summarizing the text that it gets. And so we chain those together, saying first we use the URL fetcher, then we use the social media agent, and we display the result. So with that, we would say, hey, here's the website we want you to go to, and it goes and gets it, spits out the social media post as the result. So again, you can configure any sort of chain you want to meet the user's needs, and you can also, if you want, give user input instead of predefining the things that you want to do, or you can predefine steps or give user input on other steps. Another interesting example is Orchestrator. Orchestrator has a number of agents in it, and they all have different jobs that they do. So we have one agent here called the author agent, and it is kind of an independent agent. It's just is a poorly skilled writer that makes frequent grammar errors but likes to write stories. So that'll write a story, and then we have three other agents here to help us provide feedback to our budding writer and help them improve in their writing process. So we have a finder, which finds the file that they wrote and reads it into the system. We have a writer. This is not a word writer, this is a file writer, so it will write the output to a file. And then we have a proofreader. So this is kind of the brains of it. This is who the agents that will check for grammar, spelling, punctuation, continuity, all sorts of things, and offer feedback and correction. And then, so instead of just having all those agents out there doing whatever, we have an orchestrator that is to watch over our little workforce of finders, writers, and proofreaders and help them orchestrate around a task, which we'll see here in a moment. So first, when we go to run this, pardon me for a moment. When we go to run this, we instruct the author what to write about. We say, write a 250-word short story about kittens discovering a castle and save it to shortstory.md. And so it goes and does that. And then we say, hey, we've got a task for our orchestrated agents to accomplish. We say, load the student's short story from this file, generate a report with feedback across proofreading, make sure consistency, logical, all that stuff, make sure it follows these styles, and write it to gradedreport.md. And then we say orchestrate around that task. And so the orchestrator agent will see, oh, I need to read this file. And oh, I need to proofread that file and make sure it adheres to these styles. Oh, hey, those styles, I need to go get them. So I need to go fetch those too. So the what did we call it? The finder will go and it'll get the file, it'll get the two styles that we referenced, and then it'll provide that all to the proofreader. And the proofreader will then generate its report. And when it's done with its report, it will send its report to the writer agent, and the writer agent will write that report out. So again, I hope you're kind of seeing some of the possibilities here. These haven't been impossible before. It's just much easier now with MCP to be able to do these things. Before, you would have had to write code for each one of these things, and maybe they would have just been simple Python files. Maybe it would have been, a whole library of things that you needed to write to make this all work. But now, you just define some agents, give them some prompts, and tell them what to do. It's become a lot easier to work with AI in these ways. Looks like we're making progress down here. We have our results from our Postgres tool, and it's now processing the results. So we'll see what it comes to here in a few minutes. As we are waiting for that, let's talk maybe just a little bit more about um, MCPs. Um, so I was watching uh, uh, an educator the other day, Kent C. Dodds. He's well known in the React world, and he's decided to train people on MCPs, which I think is great. And his whole thing was kind of that Jarvis is now possible. While it's technically well, some of it has been possible for a while now. It's just been really difficult to do. Not because the tasks are necessarily hard anymore, but because it's just a lot of work to get everything coordinated and working together. Um, so Jarvis, if you don't know, is a character in artificial intelligence in the Avengers movies. Tony Stark, who is Iron Man, made Jarvis and uses him in many ways throughout the movies. Jarvis is a very helpful AI agent. He goes and fetches data. He books flights. He tracks people. He displays holographic images and everything. So some of those things we don't have the technology for yet, but others of it we do. And those things are made a lot easier now with MCP. So the future is looking great if we're talking about AI agents and the possibilities there. Okay, we got our result down here. The films with the highest rentals, it got it right this time. Bucket, Brotherhood, Rocketeer, Mother, Scalawag, Duck, and many others. So it was able to correct its errors. So there you have it. That's the demo I wanted to do today. I hope to do a few more of these with vibe coding or with other agents and other things as I learn more and use them more. But please, I would love to know what you're learning about AI. Please drop comments below, or if you have questions, feel free to drop them below. Um, Thanks again for taking some time to look at this with me, and hope you all have a good time vibe coding and learning about AI.